Morning, everybody. It is Thursday, December 17th. We are getting so close to winter break, and I know that'll be welcome for everybody. Get a little break, get a little R&R. This is in case you missed psychology for Thursday, December 17th. And if you're watching this, that means you probably weren't able to make it to class today, and that's okay. I hope you're well, and I hope those around you are well. Hope you're finding some time to relax, staying caught up, and just doing okay. Miss seeing you guys. So obviously, if you're paying attention to videos or you're making it to most of the classes, you know that we're done with our journals for the dream project. I'm not going to make any big mentions of the dream project today other than to write down your dreams as you're having them. Other than that, just keep up. All right. So obviously that kind of cuts down our day a little bit. And I thought I'd reshare the schedule with you guys for the next 4 classes. Today, what we're going to do is we're going to start looking at some lower brain structures. And tomorrow, we're going to wrap up those lower brain structures. Monday is going to be the test day on chapter 3 that we're doing. And then Tuesday is going to be kind of a makeup day. People that are owing me work, those people are going to be expected to be in class. People that don't owe me work are going to be able to take the day off and do whatever they need to do. Either way, please reach out if you have questions and let me know. So your reminders, your reward for having all your work done is that Tuesday off. So, check the boxes, get the stuff done, get it turned in. And that way I can update your grades over Christmas break and we can see how you're doing. And so get that late work done. Okay. So today, like I said, we're going to be looking at some lower brain structures, talking about what they do, talking about the lower brain just in general. And when we get done, I'm going to let you guys go for today. Again, that might be an opportunity for some of you guys that are a little bit behind to get caught up. And as always, if you have questions, please feel free to reach out to me and ask for help if need be. Okay. All right. So we're going to look at 3 slides today, 3 slides today, 3 slides tomorrow, and go through those. So again, screenshot as needed, or write the notes down, pause if you need to, pause the video so you can see the screen. So, all right, there we go. So far, let me get rid of this Explore tab. This is kind of annoying. So far, we have talked about, just neurons and how they work, some characteristics of the nervous system. We've talked about the central nervous system and the spinal cord and how that works. We've talked about the peripheral nervous system and all the different parts of it. We talked about the cerebrum, which is this part out here, the hemispheres and the lobes and what they all do and things like that. So what we're going to finish up with is we're going to talk about all these, well, not all, can't do all. We don't have enough time for that. I wouldn't have enough time for that in a regular year. We're going to talk about all these structures that are under here. All right. And we're going to look at most of this stuff that has arrows pointing to it, and actually a couple things more, to be totally honest. So what I need you focusing on in this part is what does it do and what might happen if something were to go a little bit wrong with it. And so we're going to start looking at the lower brain. And what I need you guys to understand is, while all this stuff that we talked about so far is great, the cerebrum, the cerebral cortex, which is the outer part, what makes you, your ability to see, your ability to smell, your ability to move, that's all, man, that's what makes you. So that's what makes it awesome. But at the same time, you don't need any of that to live, to just live. Theoretically, if I took a scalpel and I cut away all of this, you wouldn't die. You wouldn't do anything. You wouldn't move. You wouldn't think. You wouldn't be able to eat on your own, but you wouldn't die. And so a lot of these structures that we're going to look at over the course of the next 2 classes are going to be ones that have roles in things like emotions, survival, things that you don't necessarily have to consciously think about to make sure your body does. And so I always kind of say the cerebrum is like the smart helmet that protects all this stuff. So kind of think of the cerebrum like it's a crash helmet that protects all the stuff that keeps you alive. Okay. Now the lower brain structures are generally pretty common in different kinds of organisms that have, these things. And so animals and humans have lower brain structures that help regulate their basic functions, like breathing and their heartbeat, like emotion and balance and excuse me, signaling other body systems to work. And so as we're looking at these, understand that there are very similar structures in your dog or your cat or a raccoon that you might see out in the forest, or the deer that you hunted, last fall or whatever. Those are going to be very common structures. Okay, so we're going to start off by looking at the brainstem, this piece right here. Okay, and my next thing has a diagram, but I'd like to show you in the overall diagram that we're going to be looking right here. We're going to talk about the reticular formation or reticular activating system. We're going to talk about the pons, and this arrow here points to a place called the medulla oblongata. We'll get into that on the next slide. All right, so looking at that brainstem, and again, here's kind of they've kind of pulled the brainstem parts out here so you can see them, but then they've also got them faded in color in the whole brain model. Obviously, brainstem is really important to your overall survival, but trying to go through all these things, I think one of the most important things I can tell you is it is the oldest and innermost region of your brain. And what I mean by that is when I say oldest, I kind of have a twofold part to this. We know that every organism that's ever been on this planet that had a brain has had a brainstem. Okay, some of these other structures in the cerebrum and other things, we don't necessarily know that all those things existed in every animal throughout history. We don't know that every dinosaur had a parietal lobe. We don't know that, the amygdala was fully formed, but we do know that they most likely had brain stems, at least as sure as we can be. The other reason why I can say it's the oldest part of the brain is because it is the first part of your brain that developed. Your brain stem was the first part of all of this that came into being. It's also the innermost region because if you look at where it's located, I need you to imagine a skull around this, a nose up here, some eyes right here. And when you think about that, you're talking about something that is like dead center, connect the dots, in there. And therefore, it's protected. Your vertebrae, your skull, all this other stuff, everything that makes you and me pretty and smart and things, protect this because it is vital to survival. Now, we're going to talk about three pieces that are in there, three parts. The first one is the medulla or the medulla oblongata. And the medulla, as you can see right here, is like an inner brain structure, probably located right about there. Okay. And it deals with autonomic functions, those automatic things that your body does to help keep you alive. It is your body's life support system. Okay. It controls things like breathing. Okay. The process of breathing in and out, or the rate of breathing in and out. It controls heart rate, making sure you're getting enough blood to everything in your body to make it work, especially the brain, obviously. Blood pressure, as well as like your sleeping and waking cycles. There's even some things in there that it controls, like vomiting and digestion and things like that. Obviously, when you look at this, I'm just more or less gonna simplify it as best I can. The medulla is your body's life support system. If something were to happen to your medulla, you're done. All right, you're done for. In the movies, when people do that thing where they break someone's neck, they're shearing off vertebrae and they're cutting the medulla. If you've ever seen the ones where someone walks up and puts a hand over their mouth and stabs somebody in the back of the head with a knife, they're aiming for the medulla. I don't know how easy it would be to do that. I don't know if that's realistic. I can't say that for sure. But if your medulla goes down, you will effectively be brain dead. They can keep you on machines to keep you alive, keep your body working, but the second they disconnect the machine, it's unfortunately it's over. I have yet to be able to find any real fix for anything that goes wrong in here. Okay. So obviously a very important part of who and what you are. The next part is the pons. The pons are kind of like this, I almost call it like an Adam's apple. It sticks off a little bit here. It's not truly where your Adam's apple is. It's deep in there again. And what it does is it's like a control center, but it's also connecting tissue between different parts of the brain. It allows the thalamus, which we'll talk about a little bit later, and the cerebellum, which we'll talk about later, and the medulla to work together. But when I say connecting tissue, it really kind of allows different parts of your brainstem and lower brain to be able to function together. So it acts like a unification point. It also contains some really important cranial nerves that control things like smell and sight and things along those lines. And so your pons as a junction point are really important. If something were to happen to your pons, in case of malfunction, those different brain structures might not be able to work together. And again, I think we're more or less looking at brain death if something were to happen there. Last but not least is your reticular formation. And it's not labeled on this one, but your reticular formation is in here, like right in this area. It kind of stretches around here. And what the reticular formation, sometimes it's called the reticular activating system, what it does is it plays a role in arousal and consciousness. Now, when I say arousal, I'm not talking like, sexual arousal. I'm talking like awake versus asleep. So it kind of controls the amount of activity level going through the body, like the difference between you being tired and what your body can do, and you being asleep and what your body can do, and you being like at your most awake and what your body can do. I've always pictured the reticular formation like it's a garden hose. And when the garden hose is fully open, water's flying out of it, you're awake. But when you start to get a little sleepy, let's imagine that you kind of crimp the hose a little bit and just let a little water trickle out the end. That's like when you're dozing off. If your reticular formation ever closes completely, that ain't good, y'all. Okay. And so basically, those are the jobs of the three things. And if I looked at you and I said, what happens if something becomes damaged? Basically, the answer is brain death. And brain death equals, being on a machine or being dead. Okay. Not a lot of treatment for a lot of injuries in these areas, not a lot of treatment for any of the different problems that can happen. Last slide for today does refer to that thing called the thalamus. Now, actually, if I go back, the thalamus sits here at the top. Kind of looks like it has little hands off the front, okay? But this next diagram kind of maybe does a little bit better idea of giving you the true where it is. So this piece right here is the brainstem, and obviously the thalamus sits on top. And so the thalamus is a really important structure. It sits on top of the brainstem, okay? It's up on top there. Obviously, you can see in the reddish color. It's really kind of, they're not really egg-shaped, but they're kind of, there's this Easter candy I really like. And they're like these chocolate, they're flat on the bottom, and they're like these chocolate-covered marshmallow eggs. And when I was a little kid, I used to lick both sides of them and stick them together. And that's kind of what the thalamus looks like to me. And so you have these two fused structures. Obviously, you can see it really well when it spins around, and you can see the front view or the back view on the diagram. So if you want to pause the video to get a look at that, you can. Now, what the thalamus does is it acts like a relay center. When a message travels up your spinal cord to your brain, it gets to the thalamus, and the thalamus goes, here's what we're dealing with. And so here's where this message needs to go. Here's all the places, or the one place, or whatever this message needs to get to. And so I equate it to, and I don't know if you guys would understand this, how phone operators used to be. You used to have to call the operator to call a number, and you would say, connect me to blah, 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 and that person would connect your call. The thalamus gets things to the right place. It's like the librarian who knows where all the books are. It's not only getting the book for you, but then when you bring it back, it's putting the book away. Okay. And so the thalamus is kind of the tour guide. It's the director. It's the information desk. It gets everything where it's going. And then by the same token, when my brain says, hey, I'd like to move my knee, I'd like to move my leg, I'd like to lift my leg up, the thalamus, message goes to the thalamus goes, yep, knee, boom, and sends it to that spot, gets it on the right neural path. So think of it like it's a tour guide of your body, and it always gets things to the right place. However, if a problem were to occur, hypothetically, if a problem were to occur, what would happen is maybe the message wouldn't get to where it was going. Maybe it's a tour guide who's on their first day someplace, and instead of sending you to X-ray, they send you to lab. And instead of sending you to the waiting room, they send you to the delivery ward. Okay. Now, they're not going to do it every time. I've never found a case of someone whose thalamus is so that it's literally just randomly, like you're going like, hey, I really want to run, and you just pee. I can't find anything that's screwed up. Obviously, I know that if you were to develop any major problems with your thalamus, I'm not saying you die, but normal would definitely be odd. Okay. All right. So we kind of looked at the brainstem, 3 structures there. We looked at the thalamus, 1 structure there. Keep writing down your dreams. And that's more or less what we've got for today for you. Tomorrow, we're going to talk about the hypothalamus. We're going to talk about the amygdala. We're going to talk about the hippocampus. And we're going to talk about the cerebellum. And that's kind of going to wrap things up for us in this one. So again, if you have questions, please ask. And have a great day, guys. Bye-bye.